Right now, as you watch this, the top of your head is aging faster than the bottom of your feet. Not by much. We're talking about a difference so small you'd need the most precise atomic clock ever built to measure it. But it's real. And it's been measured. In 2010, physicists at NIST, the U.S. National Institute of Standards and Technology, placed two atomic clocks just 33 centimeters apart. One slightly higher than the other. The higher clock ran faster. Measurably. Repeatably. Undeniably. Your body is not a single moment. It's a gradient of time. Every claim I'm about to make in this video sounds impossible. Time slows down when you move. Time runs faster on a mountain than in a valley. An astronaut returned from space 5 milliseconds younger than his twin brother. NASA measured that. In 1971, physicists put atomic clocks on commercial airplanes. The clocks disagreed by 273 nanoseconds when they landed. Every one of these has been measured, verified, replicated, and you can look them up yourself. So why does nobody teach you this? Why does your physics textbook still draw time as a straight line with an arrow? Past on the left, future on the right. That picture is wrong. Not a little wrong. Fundamentally wrong. Einstein proved this in 1905. That's 121 years ago. Your textbook is 121 years behind. And most people walk around with this poetic idea that time is a river. It flows. It carries you forward. Beautiful image. But ask yourself, how fast does the river flow? 1 second per second? That's meaningless. That's like saying a table is 1 table long. Time doesn't flow. Time doesn't push you anywhere. And by the end of this video, you'll understand why. Let me show you. Try something right now. Count to 60 seconds in your head. Just sit there and count. 1, 2, 3. You think you're tracking time, but what you're really doing is running a very specific, very personal program. And here's the strange part. Not everyone runs the same program. Some of you, when you count, hear a voice in your head. You're literally speaking to yourself. Subvocalizing. 1, 2, 3. Like reading aloud without moving your lips. And if someone interrupts you, asks you to speak, to answer a question, you lose your count. The machine jams. The voice can't do two things at once. But others, and this is where it gets interesting, don't hear a voice at all. They see images. A tape measure with numbers on it, clicking past like a ticker tape. Click, click, click. And if you're one of these people, you can actually read a newspaper while you count time. You can sort your socks, check a laundry list, look at patterns in the weaving, and still keep that mental tape measure clicking perfectly. Two completely different systems. Two completely different machines. Running inside two different people's heads. Producing the same answer. This tells us something fundamental. What you experience as the passage of time is just a mental construct. A pattern-matching game your brain plays. It varies wildly from person to person. It is not a universal constant. It's a biological hallucination. Don't believe me? Try this. Close your eyes for 10 seconds. Seriously. Close them. Now open them. How long did that feel? 8 seconds? 12? Your brain constructed that duration. It wasn't measured. It was guessed. And the guess was wrong. So when we talk about physics, when we talk about the actual universe, we have to throw your brain out the window. We have to stop talking about how time feels and start talking about what it actually is. In physics, we have to be operational. That means we don't ask what is the essence of time, because that's a question for philosophers who enjoy arguing over coffee. We ask, how do we measure it? And the answer is almost disappointingly simple. Time is just a way of ordering events. That's it. Imagine you have a deck of cards. You lay them out in a row. You can say the jack is before the queen and the king is after the queen. The cards aren't moving. The table isn't flowing. The order is just a structural property of how the cards are arranged. Time is the table. Events are the cards. When we say time passes, we're just reading the cards from left to right. Nothing is flowing. Nothing is pushing. We're just reading. Now this brings us to the biggest mistake everyone makes. You think time is a container. You imagine the universe is a big empty box. And time is a clock on the wall of that box, ticking away. Even if the box is empty, if you removed all the stars, all the planets, all the atoms, all the light, you think that time would keep ticking. Tick, tick, tick. Wrong. This is the Newtonian view. And it's dead. Time is not a background stage. Time is a measure of change. If absolutely nothing in the universe changes, no atoms vibrate, no light moves, no energy shifts, then time stops. It ceases to have meaning. You cannot define a second without a physical process to mark it. A swinging pendulum, a vibrating quartz crystal, a cesium atom oscillating 9, Ibai Joshar, Lobai Sanchur E, Set Sense, Setanta times. Time is not separate from the stuff in the universe. Time is a property of the stuff. Your physics teacher drew a timeline on the board. A straight line with an arrow pointing right. Past on the left, future on the right. That picture is wrong. It assumes time is a container, a background that exists whether or not anything happens inside it. Isaac Newton thought that. Albert Einstein proved him wrong. In 1905, that's 121 years ago, your textbook is 121 years behind. And here's what Einstein helped us see instead. Time is a property of the universe, not a stage the universe performs on. Think of it this way, saying time exists without change is like saying temperature exists without molecules. It doesn't. It can't. The measurement and the thing being measured are inseparable. Like temperature is a property of molecules moving. No molecules, no temperature, no change, no time. This is where your intuition fights back. You say, but time makes me get older. Time causes the milk to spoil. No, it doesn't. And the reason why reveals one of the most dangerous tricks your language plays on you. And here's why your intuition fights back so hard. Because your language, the very words you use every single day, is lying to you. Think about how we talk about time. Time heals all wounds. Time flies. Time waits for no one. Notice something? In every single one of those sentences, time is the subject. Time is doing something. Time heals. Time flies. Time waits or doesn't. Your language treats time like it's an agent, like it's a worker clocking in, rolling up its sleeves, and doing things to the universe. But here's the problem. Time is not an agent. Time doesn't do anything. Time doesn't heal your wounds. Biological processes do. Time doesn't make you age. Cellular decay does. Time doesn't move the planets. Gravity does. Time is a ruler, not a worker. Think of it this way. You measure the height of a building with inches, but you'd never say inches built that skyscraper. You measure your own height with centimeters, but you'd never say centimeters grew me to 6 feet tall. That would be insane. But that's exactly what you do with time. Every single day. You take the ruler, and you pretend it's the worker. And once you see this trap, you cannot unsee it. So let's pause here, because we've already broken 3 things you thought you knew. First, the river metaphor, poetic, but meaningless. Time doesn't flow. Second, time isn't some mysterious force. It's a measurement of change. And third, your language has been tricking you into thinking the ruler is the worker. Now here's where it gets really weird. Because that ruler, the one we just talked about, it bends. In 1905, a 26-year-old patent clerk in Switzerland, a guy whose professors literally told him he'd never amount to anything, published a paper that shattered our understanding of reality. His name was Albert Einstein. And what he discovered was this: time does not tick at the same rate for everyone. Now, I know you've probably heard that before. Time is relative. It's on t-shirts. It's in movies. But I don't think most people truly understand what it means. So let me give you a picture. Imagine you're in a car. You're driving north at 100 kilometers per hour. All of your speed, 100% of it, is going north. 0 is going east. Now, you turn the steering wheel slightly to the right. Now some of your speed is going east. But here's the key. Your total speed hasn't changed. It's still 800. You just redirected some of it from north to east. This is exactly how space and time work. Everything in the universe is always moving through space-time at the same total speed, the speed of light. Always. No exceptions. When you're sitting still, not moving through space at all, 100% of your speed goes through time. Time ticks at its maximum rate for you. But the moment you start moving through space, you're turning that steering wheel. You're redirecting some of your speed away from time and into space. And that means time slows down for you. The faster you move through space, the slower you move through time. And here's where it gets truly mind-bending. A photon, a particle of light, moves through space at the maximum possible speed. It has turned the steering wheel all the way to the right. Every last bit of its speed is going through space, which means none of its speed is going through time. For a photon, time does not pass. Let that sink in. A photon that left a star 13 billion years ago and hit a telescope last Tuesday experienced no time at all. From the photon's perspective, those 13 billion years, 0 seconds. The entire universe frozen. Look at the clock on your screen right now. See those seconds ticking by? That ticking that's not time doing something to you. That's your speed through time being displayed on a device. And that speed, it's not constant. It's not fixed. It changes based on how fast you're moving and how strong the gravity around you is. This isn't philosophy. This is engineering. The GPS satellites orbiting above your head right now, they experience time differently than you do. Their clocks tick faster because they're further from Earth's gravity, and slower because they're moving at orbital speed. The net effect, about 38 microseconds per day. That sounds tiny. But if engineers didn't correct for this, if they ignored Einstein and pretended time was the same everywhere, your GPS would drift by about 10 kilometers every single day. Your phone would send you into a lake. And remember that counting voice in your head? The one ticking 1 Mississippi, 2 Mississippi? That voice is generated by neurons firing in your brain. And the rate those neurons fire, the speed of those electrical signals, is governed by the same physics. Time dilation doesn't just affect clocks on satellites. It affects the clock inside your skull. But Einstein's discoveries didn't stop with speed. Because in 1915, he published something even stranger. But to understand what he published in 1915, we need to go back to the thought experiment that changed everything. The one that started on a train platform. Imagine you're standing on a train platform. A train shoots past you at enormous speed. At the exact same instant from your perspective, lightning strikes both ends of the train, front and back, simultaneously. Simple enough. 2 flashes. Same time. But now think about the person sitting in the middle of that train. They're moving toward the front flash and away from the back flash. The light from the front reaches them first. The light from the back arrives later. From their perspective, the lightning strikes were not simultaneous. The front was hit first. Same event. Same lightning. Different timing. And here's the key: neither of you is wrong. Both observations are equally valid. There is no cosmic referee to say who saw it correctly. Einstein realized something that should terrify you. If 2 people can disagree about when something happens and both be correct, then time itself cannot be absolute. Time is not a universal clock ticking the same for everyone. Time is relative, personnel, bendably. And in 1915, he pushed this even further. In a paper called The General Theory of Relativity, Einstein showed that it's not just speed that bends time. Gravity does it too. The closer you are to a massive object, a planet, a star, a black hole, the slower time passes. Time near the floor of your room runs slower than time near the ceiling. Your feet age slower than your head. Not because of some mechanical failure. Because massive objects curve the fabric of space-time itself, and time is part of that fabric. Think about that. A 26-year-old patent clerk. No lab. No research team. No supercomputer. Just thought experiments. A train. A beam of light. An elevator, and the courage to follow the mathematics wherever it led. Even when it led to the destruction of absolute time. Even when it told him the universe was stranger than any human being had ever imagined. Einstein showed us time bends with speed and with gravity. But how do we know? Not from thought experiments. From measurements. Hard, cold, undeniable measurements. In 1971, 2 physicists named Joseph Hafele and Richard Keating did something beautifully simple. They took 4 cesium atomic clocks, the most precise timekeeping devices on Earth, and put them on commercial airplanes. Regular flights. They flew east around the world, then west. When the clocks landed, they compared them to identical clocks that had stayed on the ground. The times were different. The eastbound clocks lost about 59 nanoseconds. The westbound clocks gained about 273 nanoseconds. Exactly as Einstein's equations predicted. Time dilation, measured on a commercial airplane, published in Science magazine, 1972. You can look this up. But here's an even stranger piece of evidence. And this one happens every second of every day above your head. Cosmic rays from deep space slam into molecules in the upper atmosphere and create particles called muons. A muon lives for about 2 microseconds. That's 0. 0, 0, 0, 0, 0, 2 seconds. At that lifetime, even moving close to the speed of light, it should decay long before reaching Earth's surface. But it doesn't. It reaches the ground. In huge numbers. Why? Because muons move at about 95% the speed of light. Time dilation stretches their life from our perspective by a factor of roughly 5. The muon is a time traveler, and it doesn't even know it. Einstein proved time bends. Haffele and Keating measured it. But why does time seem to have a direction? Why can you remember breakfast but not dinner? One man figured out the answer 50 years before anyone believed him. His name was Ludwig Boltzmann. And the story doesn't end well. In the 1890s, an Austrian physicist named Ludwig Boltzmann proposed something radical. He said that heat, pressure, temperature, everything we feel in the physical world could be explained by the motion of tiny invisible particles. Atoms. Today, that sounds obvious. Back then, it was heresy. The scientific establishment, led by Ernst Mach and Wilhelm Ostwald, two of the most powerful physicists in Europe, didn't just disagree with Boltzmann. They attacked him. Publicly. Relentlessly. Atoms don't exist, they said. You can't see them. You can't measure them. They're a fantasy. Boltzmann spent years defending his work. He gave lectures. He published papers. He debated. And he lost. Not because he was wrong, but because the tools to prove him right didn't exist yet. In 1906, Ludwig Boltzmann took his own life. He was 62 years old. Months later, Mund's experiments confirmed that atoms were real. Today, if you visit his grave in Vienna, you'll find an equation carved into his tombstone. S colomine clog vu. That equation describes entropy. And entropy is the reason time has a direction. Boltzmann was right. He just didn't live to see it. This is a lot. Take a breath. Let's recap what we know so far. Your sensation of time is a brain construct, a biological hallucination. Time itself is a flexible dimension that bends with speed and gravity. Einstein proved it. Haffele and Keating measured it. And Boltzmann died for the next piece of the puzzle. Now here's where it gets beautiful and deeply strange. Why can't you remember the future? Seriously. You remember breakfast. You remember what you wore yesterday. You can picture your 10th birthday party. But you cannot, no matter how hard you try, remember what will happen tomorrow. Why not? If time is just a dimension like left, right, or up, down, why can you only look in one direction? Here's a simple experiment. Imagine I film an egg falling off a table and smashing on the floor. Yolk everywhere. Shell fragments. A mess. Now I play the film backward. The shattered pieces leap off the floor. The yolk reassembles. The shell closes around it. A perfect egg flies back up onto the table. Every single person watching this, every single one would say, "That's fake." That's the film played in reverse. But why do you know that? The laws of physics don't care. Newton's laws work perfectly in both directions. Every equation governing those atoms works identically forward and backward. There is nothing in the fundamental laws that says the egg can't reassemble itself. So why does it feel so obviously wrong? Because of what Boltzmann discovered. There is one way for that egg to be whole. One specific arrangement of shell, membrane, yolk, and albumin. One configuration. But there are billions of ways for it to be broken. Billions upon billions of possible arrangements of scattered fragments. So if you shuffle the pieces randomly, if you let physics do its thing without interference, you will always move from the one arrangement to one of the billions. From order to disorder. From the unlikely to the likely. That's entropy. And it only goes one direction. Remember that mental tape measure, the one clicking forward in your head while you count click? Click, click, that clicking sound, that's entropy. Every click is the universe moving from a less probable state to a more probable state. The tape measure doesn't click backward because there are astronomically more states ahead than behind. Your counting experiment isn't just a brain trick. It's an entropy tracker. And here's the line that changed everything for me. You are a disorder detector. Your sensation of time flowing, that feeling of seconds passing, of life moving forward, of getting older is actually just your brain registering the increase of messiness in the universe. You don't feel time. You feel entropy. And if hypothetically the universe ever reached maximum entropy, maximum disorder, every particle spread out perfectly evenly, no gradients, no structure, no difference between here and there. The arrow of time would vanish. Not slow down, not reverse, vanish. Because there would be nothing left to become more disordered. The tape measure would stop clicking. And the sensation of time, your sensation of being alive in a moment, would cease to exist. So your brain is a disorder detector. Your counting experiment is an entropy tracker. But here's an even deeper question. What about now? What is now? You think you know. Right now feels obvious. It's this moment. The one you're in. The one where you're watching this video, hearing these words, sitting wherever you're sitting. But your brain is doing something sneaky. It's taking a tiny slice of sensory input, about 80 milliseconds of data, and packaging it as the present. That's not the universe's present. That's your present. A custom-built, neurologically constructed window of immediacy. And here's where it gets unsettling. If you and I are standing next to each other, our now is effectively the same. The difference is too small to measure without atomic clocks. But if you're on a planet a million light years away and you start walking, just walking, a casual stroll, your definition of now slices through the universe at a different angle than mine. What you consider right now might be in my future, or my past. Depending on which direction you walk, there is no universal now that covers the whole universe like a blanket. Think of it this way. The universe is a loaf of bread, a four-dimensional loaf. Every event that has ever happened or ever will happen is baked into that loaf. And now is just a slice. Your slice. And the angle of that slice, how you cut through the loaf, depends on how fast you're moving. Or think of it like a film reel. Imagine the entire universe past, present, the nexting proof. Future is a reel of film sitting on a shelf. Every frame already exists. The Big Bang is frame 1. This moment is frame trillions. The last star dying is near the end. Nothing is being created. Nothing is unfolding. The film is already complete. What we experience as the flow of time is just a projector scanning one frame at a time. But the film, all of it, is already there. Has always been there. You're not watching time unfold. You're watching a projector scan, a film that was always complete. When you stop forcing the universe to fit your intuition, when you start treating time like a dimension, like height or width, suddenly the equations work. Suddenly, the universe makes sense. Not comfortable sense. Not easy sense. Mathematical sense. But we're not done. Because everything I just told you, time bending, Entropy's arrow, no universal. Now all of it has been measured. Down to the centimeter. Down to the millisecond. Let me show you. In 2010, physicists at NIST, the U.S. National Institute of Standards and Technology, did something extraordinary. They placed two aluminum optical clocks just 33 centimeters apart. One 33 centimeters higher than the other. About the distance from your desk to your monitor. The higher clock ran faster. Not theoretically. Not in a simulation. Measurably. With a precision of 1 second in 3. 7 billion years. Your head ages faster than your feet. Not by much. We're talking about a difference of about 1 part in 10 to the 16th per meter of height. But it's there. It's been measured. And it means something profound. You are not a single moment. You are a gradient of time. Every atom in your body is aging at a slightly different rate. Try this. Hold your hand above your head. Now put it on the floor. Your hand just traveled between 2 different time zones. The difference is unimaginably tiny. But it is real. And NIST proved it. Now here's a measurement at a bigger scale. In 2015, astronaut Scott Kelly boarded the International Space Station. He stayed for 340 days, orbiting Earth at 600 kilometers per hour. When he came home, scientists compared him to his identical twin brother Mark, who had stayed on the ground. Scott Kelly was 5 milliseconds younger than his twin. 5 milliseconds. That's not a thought experiment. That's not a calculation on a blackboard. That's 2 brothers, born on the same day, one of whom is now measurably younger because he moved faster through space. Your physics textbook said time is absolute. Einstein proved it's not in 1905. Hoffele and Keating confirmed it in 1971. NIST measured it between your head and your feet in 2010. Scott Kelly lived it in 2016. Your GPS corrects for it every single second of every single day. And yet somewhere right now, a teacher is drawing a straight line on a board. With an arrow. Past on the left. Future on the right. Think about that. What have we learned? Time is not what you think. It's not what your teacher taught. It's not what your brain tells you. It's a flexibly dimension. It bends with speed. It curves near mass. It has a direction only because of entropy. And there is no universal now. It's not poetry. It's not philosophy. It's geometry. And we have measured it again and again and again. But there's one more question. The deepest one. Remember that film reel? The one where every frame already exists? Now run it backward. Frame by frame. The last star dies. Galaxies collapse. The universe shrinks. Hotter. Denser. Smaller. The laws of physics start to blur. Matter melts into energy. Space and time curl in on themselves. And then you hit it. Frame 1. The Big Bang. Everything we've talked about, entropy, time dilation, the block universe, all of it emerges from that frame. But here's the question that haunts every physicist alive. What came before frame 1? And the honest answer is, the question might not make sense. Stephen Hawking put it like this. Asking what happened before the Big Bang is like asking, what is north of the North Pole? It's a grammatically perfect sentence. Every word makes sense on its own. But the question itself has no answer, because north ends at the North Pole. There is no more north. The concept itself runs out. Time might work the same way. It doesn't stretch back forever. It doesn't have a before. It simply starts. And here's what keeps nagging at me. That counting voice in your head, the one we started with, 1, 2, 3. What if the tape measure doesn't stretch backward? What if there's no click before click 1? What if the counting machine had an on switch and before that switch was flipped? There was nothing to count? Not silence. Not darkness. Not empty space waiting to be filled. Nothing. No time to be empty in. But here's what keeps physicists up at night. Even after everything we've learned, we still don't fully understand time. Here's the dirty secret of modern physics. We have 2 theories. 2 of the most successful theories in the history of science. General relativity, Einstein's masterpiece, tells us time is dynamic. It bends. It stretches. It curves near massive objects. Time is part of the fabric. Quantum mechanics, the theory that gave us smartphones, lasers, and MRI machines, treats time completely differently. In quantum mechanics, time is a fixed background, a stage that never changes. You put your particles on the stage, and the stage just sits there. Both theories work spectacularly well. General relativity predicted gravitational waves detected in 2015. Quantum mechanics predicts the magnetic moment of the electron to 12 decimal places. Both verified. Both battle-tested. But they cannot both be right about time. One says, time is a player. The other says, time is the stage. And right now, no one on Earth knows how to reconcile them. Some physicists think time might be emergent, not fundamental. Maybe time isn't woven into the universe at the deepest level. Maybe it arises from something deeper. Something we haven't found yet. Like temperature arises from molecules, remember? Maybe time arises from something else. We've measured time dilation to 18 decimal places. We've confirmed Einstein's predictions with atomic clocks, with GPS satellites, with twin astronauts. We know exactly how time behaves. But we still don't know what time fundamentally is. And anyone who tells you otherwise is selling something. Which brings us back to where we started. Back to that strange experiment with counting. We are finite beings trying to comprehend the infinite using tools made of meat and electricity. It's a wonder we understand anything at all. Remember where we began? 2 types of counters. One hears a voice. 1, 2, 3. The other sees a tape measure click. Click, click. Classical mechanics was the voice counting. It worked. It got us to the moon. It built bridges and predicted eclipses. But it was limited. It couldn't handle speed. It couldn't handle gravity. It couldn't handle the very small or the very large. Relativity was the tape measure. A better tool. It could process patterns the voice couldn't handle. It showed us time bends, stretches, curves near mass, runs differently depending on where you stand. But what we really need, what physics actually runs on, is equations. And equations don't care about your tape measure. They don't care about your voice. They just describe what is. And here's the beautiful paradox. Even though your internal clock is wrong, even though your sensation of time is a biological hallucination built from entropy and neural firing rates, it still works for you. You can still boil an egg. You can still meet a friend for coffee at 2 p.m. You can still catch a flight. But isn't it better to know? Isn't it better to know that underneath the comfortable illusion, there's an engine? A strange, beautiful, terrifying engine that bends and curves and might have simply started? We've been lied to about time. All of us. By our brains, by our teachers, by our language. As Feynman once said, common sense is just the collection of prejudices you acquired by age 18. When we teach you about the curvature of space-time, we aren't just giving you new facts. We're asking you to delete your operating system. We're asking you to throw away the tape measure and silence the voice. And that's why it feels so hard. That's why your brain rejects it. You aren't just learning. You're translating against the grain of your own biology.